Okay, today we are going to talk about another theorem in calculus called the Intermediate Value Theorem. The theorem itself is rather complicated looking, but in reality its meaning is almost common sense. So when we talk about it, I'm going to give it to you in the format that is presented in the math booklet or in the math textbook. You'll take a look at it. We'll kind of see if we can decipher it mathematically, and then we'll go even farther and farther and get it down to its simplest terms. The Intermediate Value Theorem is abbreviated IVT, and that is across the board, nationwide. You can use it on the AP exam abbreviation for the Intermediate Value Theorem. And so let's go ahead and start setting up the process here. It is a function y equals f of x that is continuous on a closed interval bracket a comma b bracket. Okay, this is what we're talking about. When you look at a theorem in math, you need to make sure, first of all, that you understand all the words that we're talking about here. We have defined continuous for the last 3 or 4 days. And what are the 3 parts of a function that have to be equal in order for a function to be continuous? Left-hand limit, right-hand limit, and the point. Okay, so we know what continuous means. We know what a function is. Do you know what a closed interval is? That is a closed interval. Closed interval means it's brackets on both ends, as opposed to parentheses. Parentheses on both ends is an open interval. Okay? So when they say closed interval, it means dot to dot, not asymptote to asymptote. It's got to be distinct. Okay? This function takes on every value between f of a and f of b. Okay, another thing that you need to know about math books as far as terminology goes, whenever you see the word value, in the past we've always specified x value or y value. When you get up to college level mathematics, if they give you the word value and they don't tell you which one, it is automatically y value, always. So if they said, what is the value of this function, they want to know what the y value is. Okay? And the value in the name of the theorem is a y value. Okay? Now, just out of curiosity, does anybody understand what that means? A function that is continuous on a closed interval from a to b is going to take on every y value between f of a and f of b.
Is it possible, like, there's like a line between those would be the y values?
Mm-hmm. You are on the right track. You very much are. Okay. She said, can you say it a little bit louder? I don't know if I can repeat exactly what you said.
I can't even. There are 2, like, in one line, there are 2 dots, and it would be the y values between those 2 dots in that line.
So if you have a line segment with 2 dots, you're going to have every y value in between somewhere. That's what it's basically saying. Okay? Here is another way to say it that other books define it as. If y sub 0, oops, I wrote y sub 0 is between f of a and f of b, then y sub 0 equals f of c for some c on the closed interval from a to b. I'm going to fix this because it's going to bother me. If y sub 0 is between f of a and f of b, then y sub 0 equals f of c for some c on the closed interval from a to b. Now that's actually even more complicated than the first one sounding. But if you draw this one, it makes a lot of sense. Okay? So let's do that next. I want you to draw just a first quadrant, like so. Okay? Now, this y sub 0, would you assume that's a y value or an x value? I would assume it's a y value. And so let's put it on the y-axis someplace. Let's put it right there, y sub 0. Okay? It says that it's supposed to be between f of a and f of b. Are these two y values also?
Yes.
Yes, they are, because they say f of something. So let's put f of a at the bottom and f of b at the top. They don't have to, doesn't have to be right in the middle, but it just has to be between those two. So that's the setup. If y sub 0 is between f of a and f of b. Now I'm going to go on to the next part in just a minute. So if there's an f of a and an f of b, there's got to be an a and a b down here. Do you agree with me? There has to be an a and b that are x values. Okay? So I would like you to draw a dot where a and f of a meet on your graph, and then draw another dot where b and f of b meet. Okay. Now, when we were talking about lines a second ago, that does make sense, but I want to talk about it in terms of every kind of continuous graph. What I want you to do is come up with a function that is continuous that connects that dot to that dot. Any kind of graph you want, as long as it's a function. In other words, as long as it passes the vertical line test. So draw between those two whatever you like, as long as it's a function, and as long as it's continuous. So just pick something. Draw something between your two dots. I want everybody to do something different.
I'm thinking, that was my thinking.
Okay, yeah, I kind of figured. I figured that was your thinking face. Okay, I'm going to be real creative here. I'm going to go like this. How about that?
Oh, I did the same thing.
Okay, it's actually a slight slant. Okay, now, what I want you to do now is whatever graph you drew, I want you to draw a horizontal line from y sub 0 until it hits your graph. Does it hit more than once? If it hits more than once, put a dot at every place that it hits. Actually, that's more creative, to have it hit more than once. Who else besides Alex has it hit more than once? A couple of you? Good. Okay, now, I want you to drop a perpendicular from that same point, from one of those same points, down to the x-axis. So go vertically down to the x-axis. Is everybody landing between A and B? Yes, you are. What do you think that point is based on this setup? It is C. It's saying that y sub 0 is the y value for C, for some C that is on the interval. Didn't our C end up between the A and the B? Yes, it did. For those of you who had multiple points, do all of your points fall between the two? Yes, they do. Okay? This is the intermediate value theorem in another way. No matter how you draw it, as long as it's continuous and it's a function, you're going to fall between A and B. So let's read this again in context of the picture. Y sub 0 is between f of A and f of B. Then y sub 0 is f of C. So we could also call this f of C, couldn't we? For some C between A and B, no matter how we draw it. Now does it make sense? Hopefully it does. Okay. So, actually we're about halfway finished. So, let's move on and talk about some more practical uses of this. Okay? Talking needs to stop. F of x is a continuous function from 3 to 10. If f of 3, I don't know why I wrote the word is. I am messing up like crazy today. If f of 3 equals 6, and f of 10 equals -8, then there must be some C between 3 and 10 where f of C equals 0. Now we're going to figure out if this is true or false. So this is like a true or false question. True or false? Now, some of you can look at the words and figure this out. Some of you, this would be better if we drew a picture. Because a picture, like the old saying says, a picture is worth 1,000 words, and in math class that tends to be the case a lot. Okay? So, I'm going to come up here and draw a picture. I'm having to go to negative y value, so I'm going to draw this way. I'm going from 3 to 10. These values are x values, continuous function from 3 to 10. The independent variable is how a function is defined, and the independent variable is x. Okay, so f of 3 is positive 6, so I'm just going to eyeball that about right there. That's at 6. And f of 10 is negative 8. So I'm going to eyeball that one about right there. Does there have to be a c between 3 and 10 where f of c is 0? Yes, there does have to be. So in other words, to get from that point to that point, if I'm going to go continuous, do I have to cross the x-axis? Yes, I do. This one is true. So I don't care how weird I draw this thing. I could go like that. I'm going to cross the x-axis, aren't I? That's what this is saying. F of c is equal to 0. That is true. Okay? Now, a little bit of an extension question. What is another number I could put here and still have a true sentence?
Anywhere from 6 to 8.
So if I put 1 there, would it be true?
Yes.
If I put negative 4 there, would it be true?
Yes.
If I put 9 there, would it be true?
No.
No. If I put 9 there, it would be false. Because, well, it possibly could hit 9, couldn't it? Could I possibly go from here to here and go up to 9 and then go back down?
Yes.
Yeah, I could, but it's not a guarantee. What if I said negative 9? No, that's not guaranteed to be true. Does that make sense?
Yes, ma'am.
Okay. So that's the end of that question. So here is the picture. Well, that was a horrible arrow. Here is the picture that supports what we just did. It's a definite true statement. Okay? Let's do one more. Does f of x equal x to the third minus x minus 1, does this function have a 0 between x equals 0 and x equals 2, question mark. Okay, now I'm actually finding something instead of a true or false. Does that function have a 0 between 0 and 2? Now, let's review real quickly. What is a synonym for 0 in mathematics? A root. A solution. One more. Has to do specifically with the graph. What does a 0 look like on the graph? What? X-intercept. X-intercept is the one I'm really looking at. So the question's saying on that graph, without graphing it, is it going to have an x-intercept somewhere between 0 and 2? That's what we want to know. Okay? So first thing we're going to find is f of 0 and f of 2, the y values on either side of the problem. Okay, what is f of 0? Negative 1. What is f of 2? 2 cubed is 8, minus 2 is 6, minus 1 is 5. So, is this function going to have an x-intercept or a 0 between those two?
Yes.
Okay, can somebody tell me in a sentence why? Want to give it a shot? Because you're going from a positive y value to a negative y value. That's exactly right. We're actually going from a negative to a positive.
It's actually the other way.
Okay, but that's okay. She's right. You're going from a negative to a positive, but you're still having to cross 0, aren't you? Okay? So we need to put that more in mathematical terms. And here's how we're going to write it. Okay? Since 0 is between f of 0 and f of 2, IBT says that there will be a C between 0 and 2 such that f of c is 0. So basically I just restated IBT, putting in the numbers that we were dealing with. And that's the way it's going to look in your homework as well. Okay? Now, does that sentence make sense to you? Since 0 is between my two y values that I got here, the intermediate value theorem says there will be a c between my x values such that that x value is equal to the y value. The y value is going to be 0. Okay?